Hello everyone, here is a question based on stereochemistry. What is the total number of stereoisomers of the given compound is? Number of stereoisomers depends on number of stereocenters. Chiral centers are sometimes referred as stereocenters, and we have to include geometrical isomerism also as a stereocenter. So we have two double bonds here. Both of them can exhibit geometrical isomerism. So therefore, stereocenters due to double bonds is 2, and also we have a chiral center here because that carbon is connected to a methyl group, and then we have a methylene unit here, and then we have this entire unit, and then there is a hidden hydrogen, and therefore this is a chiral center. So therefore the total number of stereocenters in this case is equal to 3. Number of stereoisomers is equal to 2 to the power n, where n is the number of stereocenters. So therefore 2 to the power 3, and that is equal to 8. This means option B is correct. Here I have shown all the stereoisomers that are possible. So when you name it, then you can realize that we have indeed 8 stereoisomers in this molecule. So how do you name this molecule? I will just name it to 1. Maybe rest of them you can try it yourself. So this is 1, 2, 3, 4, 5, 6, 7, 8. The bromines are in 180-degree position. That means normally you call it as trans, but as per Korn-Ingold-Prelog rules, we can go for the EZ convention. So if we go for the EZ convention, then this is an E isomer, isn't it? Because the higher priorities are on the opposite side. So therefore at 2 position it is E. How about at 6 position? Here we have a hydrogen. Here also there is a hydrogen. So the low priorities are on the same side, or you can also say high priorities are on the same side. So therefore at the 6th position it is Z. And then how about at 5 position? What is the absolute configuration there? So we have a chiral carbon here, and then we have carbon on this side, carbon on this side, carbon on this side, and there is a hidden hydrogen. So the hidden hydrogen obviously gets priority number 4, that gets the least priority. And then for this carbon it is connected to hydrogen, 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 whereas for this carbon it is connected to 1 carbon and 2 hydrogens. For this carbon we can consider it as carbon connected to carbon because we have a double bond, and then 1 hydrogen. So obviously the top priority must be given to this, and then this one, and then this one. So if we are looking from this angle, then the Fischer projection we can write it this way. 4 is on our right hand side, and then 3 is on our left hand side, 1 is top, and then 2 is bottom. We can't determine absolute configuration like this because we need to bring the least priority group down. So therefore bring the 4 down, do 1 swap between 2 and 4. So 2 goes on the right hand side, and then 1 stays where it is, 3 stays where it is. This is clockwise. So this means R, but we did 1 swap, therefore the original is S. Therefore at 5 position the absolute configuration is S. So therefore the IUPAC name for this molecule is 5S. When you have geometrical isomerism as well as chiral center, you need to specify the absolute configuration first. You shouldn't start like 2E and then 5S. 5S should be mentioned first, and then 2E, and then 6Z, and then 2, 3 dibromo, and then 5 methyl oct or octa because we have a diene. So octa 2, 6 diene. That's the correct IUPAC name for this molecule.